when you stop and really look at what humanity's managed to build, quantum computers, AI that seems almost alive, rockets that land themselves, telescopes seeing back to the dawn of time, it's hard not to feel, well, pretty impressed, right? Like we've really got a handle on things. But here's this fascinating paradox that our sources bring up. Despite all that, all these incredible achievements, we've built this entire civilization, this whole technological world, without, it seems, fundamentally understanding what anything is really made of. So in this deep dive, we're going to explore a pretty radical idea. The idea that maybe we've just been manipulating structured motion all along without even realizing that motion might be the only real ingredient.
Exactly. And that's where this concept, motion theory, comes in. It's proposing a way to sort of clarify this fundamental misunderstanding we might have. Our current models in science, they absolutely work. They let us build amazing things. But as the theory suggests, maybe they aren't actually true pictures of reality's fundamental nature. They're more like incredibly effective instruction manuals that just don't explain how the engine truly works,
Okay, so if that's the big paradox, let's sort of unpack how we usually try to make sense of things. For centuries, we've built these conceptual models, right? We talk about particles, we talk about fields, forces, energy, even time, as if they're distinct things. And crucially, like you said, these models do work. They let us predict, design, build. But the material we've looked at describes these models as, well, patchwork interpretations, useful shortcuts almost. There's this great analogy in the sources. It's like flying a supersonic jet. You can fly it perfectly, land it safely, but in your head, you think the air is made of, like, invisible ghost marshmallows. You still fly the plane, no problem, but you're definitely not qualified to design the next universe.
That's a perfect analogy. It really highlights that gap, that feeling we sometimes get, that maybe we're missing something fundamental, that aha moment that hasn't quite clicked for the whole picture.
Exactly. So the jet flies, but the understanding of the air, it's just not there.
Right. And that sets the stage perfectly for what motion theory suggests is really going on underneath it all.
Yeah, sure.
It tries to cut through all that complexity. It basically says the only actual substance in existence is, get this, structured motion resolving under constraint.
Okay, hold on. Structured motion resolving under constraint. That sounds dense. Can you break that down, and what does that look like in, practical terms?
Sure. Think about a whirlpool in a river.
Yeah.
Is the whirlpool a thing? Not really, right? It's a pattern. It's water moving in a structured way. It persists, it has effects, but it's made of motion.
Okay, I see that. The whirlpool isn't separate from the water's movement.
Exactly. So structured motion is like that pattern movement.
Mm-hmm.
And resolving under constraint, that just means this motion isn't random chaos. It interacts, it adapts, it follows inherent rules, and this creates stable patterns that look like things to us. So reality, from this viewpoint, isn't made of static things. It's made of motion, behaving in these incredibly repeatable ways.
Wow. So you're saying everything is more like a dance than a collection of bricks.
That's a great way to put it. A very complex, structured dance. And if that's true, we need to translate our old language. So what we call particles. According to this theory, they're really stabilized loops of motion, like tiny persistent whirlpools.
Loops of motion.
Oh,
and fields, like magnetic fields.
Motion gradients. Think of them as areas where the flow or pattern of motion changes intensity or direction. And energy. We talk about energy all the time.
Right. What's energy in this picture?
Synchronization intensity. Imagine those dancers again. Their energy isn't some extra thing they possess. It's about how intensely and coherently they're moving together. The coordination of the motion.
Okay. Intensity of coordinated motion.
Yeah.
And forces, like gravity or electromagnetism.
Those become directional adaptations. When constrained motion patterns interact, they have to adapt, and those adaptations create directional pushes and pulls, what we perceive as forces.
So everything we thought of as fundamental stuff or actors, particles, energy, forces becomes aspects of this underlying motion.
Precisely. It collapses multiple categories into one fundamental process. Motion behaving in structured ways.
Okay, that is a massive shift. It brings us back to this idea of how we build things then. We are undeniably brilliant engineers. Humanity figures out how things behave, right? We test, we repeat, we find patterns, and then we package those behaviors into technology, phones, computers, medical devices. It's genius.
Absolutely. No question about the ingenuity.
But the critical question, the one this theory seems to force us to ask, is what is the thing whose behavior we are manipulating actually made of? We got so good at predicting the behavior, we forgot to ask about the substance.
That's the core argument. This leads to what the sources call the illusion of mastery. We've mastered predicting and repeating how motion behaves. We haven't necessarily mastered the truth of what motion is. Think about it. We manipulate electromagnetism constantly. Our whole modern world runs on it. But do we fundamentally know what electric charge is? Like at the very bottom, the theory says maybe not.
Or nuclear power. We split atoms, release incredible energy.
Exactly. We build reactors around neutrons. But what is a neutron, fundamentally? Is it a tiny ball, or is it a complex pattern of motion? We talk about energy transfer all the time, chemical energy to kinetic energy, whatever. But what is physically moving when that energy transfers? If it's not a separate substance, what's changing?
It's like we have these black boxes, we know the inputs and outputs, we can use them, but we haven't truly looked inside. But wait, isn't there a risk here? Are we just swapping one set of mysteries, like quantum fields, for another mystery called structured motion? Does it actually simplify things?
That's a really fair and important challenge. The claim is that it does simplify, fundamentally.
Yeah.
By reducing the number of basic ingredients you need to build a universe. Instead of needing matter particles and force carriers and energy and fields and maybe space-time, motion theory says maybe all you need is motion itself, behaving under constraints. One ingredient, manifesting in complex ways.
So it's aiming for a more unified foundation.
Exactly. It suggests that a lot of the weirdness in physics, like wave-particle duality, maybe that arises because we're trying to describe one thing's structured motion using two incomplete concepts, waves and particles. Those debates that still go on in physics, What is a photon, really? Is time fundamental or emergent? How does gravity actually work at the quantum level? Motion theory suggests these persist because we started with the wrong building blocks.
Yeah.
We didn't define the substrate.
As the solution is.
Stop. Go back. Re-examine the foundations. It was motion all along. That's the provocative claim. It changes the questions we can even ask.
Okay, and this completely reframes what engineers do, doesn't it? Our sources practically call them heroes of utility. It's like engineers don't necessarily need to know the fundamental what, they are masters of how to make motion do useful things.
Precisely. They are brilliant pragmatists. They find a behavior that motion exhibits, and they figure out how to harness it repeatably.
And even our most advanced tech becomes, well, just layers of motion manipulation, like a transistor in your computer chip.
Just a cleverly designed motion restriction zone. It controls the flow pattern.
Semiconductors.
Guided motion pathways, steering the flow with incredible precision.
Flying an airplane.
That's about manipulating air pressure, which is really about managing fluid motion.
Even something as abstract as AI.
You could see it as complex feedback loops trained on patterns derived from motion, whether that's motion of electrons in sensors or motion of light, or even the abstract motion of data points.
Wow. The analogy uses that we're like motion sculptors. We've gotten incredibly skilled at shaping this stuff, but we never asked what the clay itself is made of.
And that leads to a really profound thought. Civilization was built on motion ignorance. Think about that. Everything we've constructed, from pyramids to particle accelerators, we did it by stacking and controlling motion behaviors. But we thought we were stacking particles, atoms, forces, energy fields.
And it worked. That's the crazy part.
Yeah, it worked incredibly well. But the foundation, the understanding of that clay, remained, well, blurry, out of focus.
Yeah.
Again, this isn't saying past science was wrong. It was incredibly successful. It's suggesting an opportunity to deepen the understanding.
To finally see the clay clear.
Exactly. Which brings us to the idea of a motion renaissance.
Yeah.
This isn't about throwing out physics or chemistry or biology. Not at all. It's about completing them, giving them their actual substrate. It's about potentially clarifying the weird quantum stuff, the cosmological mysteries, by reframing every experiment, every interaction as fundamentally about structured, rhythmic, adaptive motion.
Imagine looking at biology that way. Life is incredibly complex, self-sustaining motion patterns.
Right. It opens up new ways of thinking everywhere.
There's a line from the sources that really sticks with me. We didn't fail. We just skipped a step. It's not about blame. It's about recognition. We built the house, but maybe we forgot to check the foundations properly. Now it's time to go back and, name the thing. Name the thing we've been pushing around and shaping this whole time.
To finally identify the clay.
So the core assertion, boiling it all down, seems crystal clear from this perspective. It's not fundamentally particles, not energy as a separate thing, not fields floating in space, not time as a river we flow down. It's motion, structured, resolving, everywhere. That's the candidate for the ultimate bedrock of reality.
So here's something for you to really chew on. If we actually start to internalize this, if we really begin to understand motion as the fundamental ingredient, how might that genuinely change how we approach science? How we look for new discoveries. What about technology? If we understand the clay, can we sculpt in ways we couldn't even imagine before, moving beyond just copying behaviors to perhaps designing new fundamental behaviors?
Yeah, what new possibilities open up when you finally know what you're working with? And that leaves us, and you, with this really provocative final thought. What does this all mean for the next big leap in human understanding now that we might finally be starting to grasp what we're actually doing when we build, experiment, and explore? What comes next?